Okay, what I wanted to do with this video is do a little further explanation on the difference between neutral and ground. Now, I did a video earlier on the three-wire system and explained something about the neutral and ground and the difference between them. But I'm going to go a little bit farther on this one and see if I can explain this a little bit more. Now, here's your power pole. You've got L1 and L2. It comes off there, and then you have a neutral. If you look at the power line coming off of the pole, you'll see two black insulated wires. That's L1 and L2, and the neutral is bare. Okay, when it comes into the main panel, now this is a main panel here, there is a connection between the neutral on the pole and the neutral bar in the panel. There is also a jumper that goes from neutral to ground. Now, this is ground here, and this is earth ground. And of course, it has a bar also. Now, I want to compare this main panel. I got my two hots coming down to the terminals here, and I got breakers. And then I've got a sub panel here. Okay, the sub panel has the ground and the neutral wired differently. Notice that my ground bar here is not connected to the neutral. They are separate, and this is the way it's supposed to be. This is how it's supposed to be designed. So I have one side of power coming in here going through, say, another breaker in a sub panel. Now, I put the sub panel in there just to illustrate the difference a sub panel is from a main panel. The sub panel cannot have the ground and the neutral connected together. Okay, let's follow a little farther out. I've got my ground coming to an outlet. The outlet ground goes over to the chassis of the load. Now you see I've got a light here, and it's got, say, a metal encasing. And this is a chassis ground. Now all that means is that when I put this terminal on here, that the ground is hooked to the body of the load. Okay, now I've got a hot lead right here, comes down to here, passes over and feeds one side of my load. I've got a neutral here that comes over to the neutral bar, comes down, goes over, and feeds the other side of the load. Okay, why do we put that extra wire in? Why don't we just use the neutral? Because it's all connected together in the panel anyway. The reason for this is the neutral is a current carrying wire. If I have power going through this, it comes from the hot over to the load, through the load, back to the load, through the neutral, and to the main panel. Okay, it is a current carrying load from here to here. I have a separate ground, which we call our safety ground, that is mounted to the chassis of the load, goes back to the ground, goes to the ground here, and over to the ground here. It should not be carrying power under normal situation. You don't want your ground to be carrying power. The problem with this is, let's say I had a loose wire on the ground. Let's say I eliminated this neutral line right here and just use the ground. I could hook the ground right to here. If I did that, it'd be a current carrying wire. If for some reason that ground wire was broken, no longer had continuity, then I would have no chassis ground on this load, and the load would be hot. That would mean power from here is energizing this entire box. So if I touch that box and I happen to be touching something else that's grounded, then I become part of the load and I get a shock. So we don't use the ground as a current carrying wire. We separate them in every panel, sub-panel, and you could call this a little panel too. They are separate. Now, why do we even have a ground? The neutral should be fine. The neutral should take care of all the power coming back, the balancing power coming back. The problem is we oftentimes get lightning strikes on power poles, on wires, maybe something in our house. We need some place for it to discharge to, rather than go into the house and burn up all the wiring in the house. So let's say I got a lightning strike out here. It would come through that neutral, go to the ground, and then go to the earth ground. And that just feeds it off. A lot of people think that power is actually going through this ground under normal circumstances. It is not. Power is not going through this. The resistance of dirt is way too high for any kind of load to go through it. And even if it did, it would create an anode of the ground wire and corrode the ground wire. So it's not a current carrying wire. And in these sub-panels, we separate it because we want to make sure it is not a current carrying wire. If for some reason, if I had connected these two together right here, okay, and then I had a fault where this wire failed, this neutral wire failed, then the load would run normally and it would go back through the ground. It would come through here, 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 and then go back through the ground and back to the panel. And there would be no, the breaker wouldn't kick off or anything like that. However, you've just made this panel hot again. So you don't want to have those connected because you want the circuit protection to kick it off if one of these fails. Certainly if I had I had a lead coming through here, going to here, and that's hot, if for some reason something burned up in this thing and I got a direct connection to the chassis of this load, I want it to kick off. I want it to kick the circuit protection off and shut it down so it's no longer hot. That's what we're talking about with this. I hope this makes a little more sense. It took me years to figure this silly thing out too, because I couldn't figure it out either. But main panels, we tie the neutral and the ground together so that we can go to the ground. By the way, that ground here, that's usually a ground rod, or it can be a water pipe. Now, there's a bunch of different codes on this, but you usually have to have a separate ground rod, not just a water pipe. So anyway, I hope this makes sense. Send me questions if it doesn't.